Hey, welcome back to the IT office. Imagine your boss is calling you because he's telling you that this device is not able to ping another device and the connectivity is not working. So what do you do? If ping is not working, is that enough to say that the device is down? What do you think about it? Okay, so let me explain you about ARP, or Address Resolution Protocol. This protocol is a fundamental protocol in the connectivity in the network, and I'm going to show you why. Okay, so see this network we have here. We have Windows 01, Kali 01, Win 03, a couple of switches. Everything is connected in the same LAN network, and your boss is telling you, hey, Windows Server 01 is not able to ping Windows Server 03. And it's telling you the connectivity is not working, the device is down, something is going on. Before going into the details, let me show you something that's very important in this case. If you run the following command, ARP-A, you will see some entries here. And let me tell you what those entries mean. So you will see an entry for this IP address 10.10.15.33, right? And you will see this MAC address that I will tell you later. This corresponds to Win 03 MAC address, okay? So is connectivity working fine or is not working fine, okay? So if you have ARP entry, it means that you have connectivity, okay? If you're able to see the entry for a device in your same subnet, because ARP is relevant only in your same broadcast domain or your same network. If you see the entry for the device you're trying to reach, it means that the connectivity is okay. Let me show you real quick how you can validate that. So let me delete this table. So with the command ARP-D, and then I run again ARP-A to show the ARP table. But you don't see the entry anymore because we deleted. Okay, so before explaining what ARP is, let me show you the ping again. The ping won't work. Then I will show you why, because that's expected for many devices in the network because some security policy. So let's run the ARP-A. You will see this entry back in the ARP table. So this is enough to tell your boss that connectivity is okay. Even if ping doesn't work, the connectivity is okay because you see the ARP entry of the device, in this case Win 03, in your ARP table. Now, what does it mean? Okay, so let me explain you a little bit about ARP. ARP, or Address Resolution Protocol, is a protocol that helps you resolve the MAC address of any device IP address, okay? So when you're pinging this device, right, and the ARP table is empty, like you see here, you don't see any entry for 10.10.15.33, the device is trying to build a packet, right? This packet will have a few fields. So one of the fields will be the source MAC, right? This is based on the TCP or OSI model. It will have a destination MAC, right? It will have a source IP, and will have destination IP, and then we have the payload, okay? This payload is basically the ping traffic or any traffic you're sending to the device, okay? So if you're trying a ping, the source MAC address will be the source MAC address of the device of the for example, in this case, Win 01 MAC address, okay? we can check the MAC address with the ipconfig all command in this device. I show you in my previous video what is a MAC address, so you can go back there and check it. So the destination MAC, this is important, okay? Because it's a physical MAC address. This information is not known by your device by default, okay? So in this case, when you're sending this ping packet for the first time, you don't have this information, okay? So I'm going to leave the question mark there. Then we are going to see more detail about this. So the source IP address is Win01 IP, which is known because this is configured in the device. In this case, it's 10.10.15.11, and the destination IP address of 03, which is, in this case, the IP you are pinging, 10.10.15.33. Okay, so all information in this packet is known except the MAC address, okay? So can this device send a packet if it doesn't know the MAC address? Well, it can't. It's not possible. So if you're trying to send a ping to Windows 03, you won't be able to send that first packet because you're missing Windows 03 MAC address in to build this packet, okay? So that's when the ARP protocol is relevant, right? Because ARP protocol will help you resolve or obtain this information missing here. Okay, so you are going to ask all the devices in the network for the MAC address of 10.10.15.33, okay? So for example, that's a broken packet that it's called ARP Request. So this packet is sending a question. Basically, what is the MAC address associated with the IP 10.10.15.33? So it's asking everybody. It will send the packet to the switch will send it to all the devices in the network, and every device in the network will receive that packet, okay? But only the device responding to that ARP, in this case, the relevant device with the IP that we are asking for, will respond that packet. So only Win03 will respond to that ARP request and will provide the MAC address in an ARP reply packet, okay? So it will tell Win01 what is his MAC address, okay? Kali 01 will receive the request, but it won't reply because it is not the device we are asking, so it is not relevant for this device to respond to these ARP requests, okay? So after the ARP request is received, the reply is received, you will see the entry in the ARP table, and then you can send these packets out, okay? So in this case, we can confirm that the connectivity is okay because we, after cleaning up the table and then showing that the entry is not in the table, sending some packets, and then checking the ARP table again, we can confirm that we have the entry for that device, even if we don't have response for the ping, okay? So that's why it's so important to understand that even if we don't have a response for the ping, because in this case, I'm going to show you why. If we have the ARP entry, that's enough to confirm that we have connectivity, okay? So let's check this ARP entry again, but we are going to use Wireshark to show the low-level details of the traffic here. So let me clear the ARP. So if we display the ARP table, we don't have here anything, okay? So let me filter by ARP and or ICMP. I'm going to filter any ICMP or ARP traffic, okay? So let me send a ping. So what is going on here? So you see, I'm going to let this run a few more times. Okay, so let's see. When we before we send this first packet, we trigger an ARP resolution. Okay, let me stop the capture. So let's check this first packet. Okay, so this is the ARP resolution. If you see here, opcode request. Okay, so what are we requesting? Well, it is pretty clear here if you expand this window a little bit. Who has 10.10.15.33 tell 10.10.15.11 is asking what is the MAC address, what is the MAC assigned to this device. Okay, so that's how the protocol works. It's asking for the MAC address assigned to this 10.10.15.33. okay, and it's telling everybody that they have to notify, or the device has to notify 10.10.15.11. So this Windows 1 is sending a broadcast packet. You see the destination, it is a broadcast, so it will be sent anywhere in the network. The switches will send those packets everywhere. So only Windows Server 3 will respond, okay, with the information. So if you see the response here, Windows Server 3, then we can check the MAC address and such, but it's telling that 10.10.15.33 is associated with this MAC address. Okay, it's telling Windows 01 that is its MAC address, its physical address. Okay, so after that process is complete, then the device starts sending the PIN packets, the ICMP packets. Okay, it's not getting response, but the reason it's not getting response is not because the ARP process didn't work, because we already saw the ARP entry in the ARP table, right? So that process is 100% completed and correct. Okay, let me try another device that actually responds PIN. So let's try, in this case, let's try Kali Linux device. Okay, so see the table. Kali Linux IP ends in 200. So I'm going to send traffic to the Kali Linux IP, and I will let you see the packets up here. So you see the PIN response. Okay, let me stop it right here. So see, same for Kali Linux. Who has 10.10.15.200 tell 10.10.15.11, which in this case is Windows 01. Okay, so Kali Linux is responding 10.10.15.200 is at 0C000C29 E6C588. Okay, if you check, for example, in the Kali Linux device, its MAC address, it is the same MAC address sent in the response, ending in E6C588. Okay, E6C588. Okay, in this case, Kali Linux is actually responding the PIN packets. Okay, if you check now Windows Server 1 and see its ARP table, okay, if you look at its ARP table, you will see both entries there. Okay, so this is enough to tell your boss, hey boss, connectivity to Windows Server 3 is working, because you have the entry. So at the layer 2 level, okay, they have connectivity at the layer 3 level because they are able to send packets to their devices. Okay, but now there is something else here, right? So this device is not responding ping because of its policies. So let me show you. In this case, if you check this device, the Windows firewall is enabled. Okay, so any ICMP traffic it will receive or ping packets, it will drop. However, if we ping from this device, for example, if we ping Windows Server 1, Windows Server 1 is responding, and we can also ping the Kali Linux device. But the reason is that in this case, Windows Server 1 doesn't have any Windows policy enabled or firewall policy enabled. So let me disable real quick this firewall for this device, just to show you that now we are able to ping. Okay, now we are able to ping, so we can confirm that connectivity was okay even before the ping. Okay, so the reason that we have ping enabled or firewall policies enabled is because sometimes we don't want to open specific ports, and we open just ports that we need, like remote desktop or Windows or HTTP or HTTPS, which is a good practice, right? But that's why ARP is very important. And all devices that work at layer 3 level, they should or they must respond ARP request, okay? And they need ARP request in order to send packets within the same network or LAN or broadcast domain, okay? So keep that in mind because that is mandatory. For example, let's say you have a new switch, right? And somebody is connecting this device to the new switch, right? And this device is trying to reach Windows Server 1 or trying to reach Windows Server 3 or the Kali Linux device, right? And it's not reaching anybody, right? But the ping, they're trying to do some ping tests, and then you go and check and the ping is not working, but then you go and check and can see that ARP is not working. So probably you don't have connectivity between the switches. If this doesn't exist, this connectivity inside the same broadcast domain, you won't be able to do the ARP request reply process, okay? Okay, so before we close the video, I want to show you some details of the ARP packets. Okay, so initially this packet is sent from using in the source MAC address header, the MAC address of this Windows device. If we can run the command ipconfig all, you will see the MAC address of the Windows device. Let me just pull this window a little bit more. Let me put it side by side, okay? So this is the source of this traffic, okay? Windows Server 01 is sending this packet to the broadcast address, okay? So the broadcast is just all F, okay, at the layer 2 level. So it's sending that packet out to any device in the network, okay? So keep in mind this broadcast is a layer 2 broadcast, okay? So you won't see any layer 3 header. So basically this is sending the packet to any device in the network. This is the generic MAC address of the broadcast address, okay? So this packet will be sent here. The switch will send it through all the ports except the port the packet came in, and the other switch will do the same, okay? Now in the response you will see that the source address at the layer 2 header is this MAC address that ends in E6, E588. Well, this is Kali Linux. Yeah, it's it will send the response using this as its source, and the destination will be the MAC address of this Windows Server device. So it will send a unicast layer 2 packet telling that this IP 10.10.15.200 is associated with this physical address, which is Kali 01 physical address, and the opcode is the reply. Okay, so basically ARP helps us get this information so we are able to send packets and complete the frame before sending any packet. Okay, so keep in mind, you cannot send, for example, this pin packet if you cannot build the frame with the destination MAC address. If you don't have this information, this packet won't be sent at any point in time. Okay, so first, before sending traffic to any device, you need the ARP entry in your ARP table. Okay, I will explain you in a later lab how to use ARP to troubleshoot, but when you want to send traffic, for example, to internet devices, you will require an ARP entry for the default gateway of your network. I will explain that more in later videos, but keep that in mind. Okay, so ARP is used inside the same broadcast domain. Okay, I hope you enjoyed this video. Don't forget to subscribe, like the video, and turn on the bell. See you in the next one.